Have you ever wondered why all planets made from the same dust and gas are so different from one another? It's one of those tantalizing questions that has piqued the curiosity of scientists and stargazers alike for centuries. Imagine a cosmic bakery churning out planets from the same essential ingredients, cosmic dust and gas. Yet the end products are as varied as a loaf of bread and a croissant. Some are giants shrouded in gas with swirling storms the size of Earth. Others are rocky and barren with surfaces scarred by billions of years of meteor impacts. And then there's our home, Earth, a blue marble teeming with life. What makes Earth so unique? How did it come to be this way? It's a captivating tale filled with cosmic collisions, life-giving elixirs, and ancient organisms that have witnessed the passage of time. So, let's unravel the mysteries of our blue planet, Earth. Around 4.5 billion years ago, a giant cloud of dust and gas started to collapse under its own gravity. Imagine a cosmic ballet, where the dancers are dust and gas swirling together in the vast expanse of space. This dance is directed by gravity, the invisible hands that pull and push, shaping the cosmos. Over time, the dust and gas started to clump together, drawn by their mutual gravitational attraction. This process, known as accretion, is like a cosmic snowball fight. The more mass an object accumulates, the stronger its gravitational pull, attracting more and more material. As these particles collided and stuck together, they formed planetesimals, the building blocks of planets. These planetesimals continued to collide and merge, growing larger and larger. Over hundreds of millions of years, they formed protoplanets, the precursors to the planets we know today. One of these protoplanets, located in the Goldilocks zone where conditions were just right, was our Earth. But it was far from the lush blue planet we know today. It was a hot, molten world, continuously bombarded by other space rocks. The heat generated by these collisions and the decay of radioactive elements caused the Earth to partially melt. The molten iron sank to the center, forming the core, while the lighter materials floated to the top, forming the mantle and the crust. This process is known as differentiation. In this early stage, Earth was like a hot, fiery furnace, but over time it began to cool down. The surface hardened, forming the first solid crust. Volcanic activity released gases trapped inside the Earth, creating the first atmosphere. This was an important milestone in Earth's history, but it was not the end. It was the beginning of a new chapter in the story of our planet. But the Earth's story didn't stop there, it was just getting started. Ever heard of the planet Theia? Let me tell you about an epic space collision. Picture this. It's around 4.5 billion years ago, and our young Earth is in its formative years. Things are pretty chaotic in our corner of the galaxy, with celestial bodies whizzing around every which way. Among them is a Mars-sized planet named Theia, and it's on a collision course with our planet. Now here's where things get really interesting. Theia doesn't just smash into Earth and bounce off like a billiard ball. No, instead, the two planets collide with such force that Theia is completely obliterated, its remnants merging with Earth's molten surface. This collision was so monumental that it's thought to have completely reshaped our planet, spinning it into a faster rotation and tilting it on its axis. But what about all that debris from the collision, you ask? Well, it didn't just disappear. The dust from the impact was flung far into space, but the Earth's gravitational pull was strong enough to keep some of it in our vicinity. Over time, this debris began to coalesce, gradually forming a new celestial body that orbits our planet. And that, my friends, is how our moon was born. This is known as the Theia impact theory, and while it's a theory, it's widely accepted by the scientific community. It explains why the moon is made of similar material to the Earth's mantle, and why it's lacking in heavier elements found in our planet's core. The Theia impact was a cataclysmic event that forever changed the face of our planet and gave us our only natural satellite. But it's also a testament to the incredible power and volatility of the universe, where collisions of this magnitude can lead to the creation of something as beautiful and enduring as the moon. So in a way, we owe our moonlit nights to a catastrophic collision billions of years ago. Water everywhere, but where did it all come from? Every drop of water on our planet has a story that stretches back billions of years, a cosmic journey that's nothing short of incredible. So, let's dive in. The origin of Earth's water is a topic that has long baffled scientists. There are a number of theories, each as intriguing as the last. One of the most popular theories suggests that water arrived on Earth through the delivery system of the universe, comets and asteroids. You see, comets and asteroids are like cosmic sponges, soaking up water and other elements as they travel through space. As they collided with Earth, they brought with them water along with other elements. Now imagine billions of these cosmic sponges over billions of years, repeatedly making contact with our planet. That's a lot of water. But the story doesn't end there. Another theory suggests that water was already present on Earth, locked up within its rocks. As the Earth heated up and volcanic activity increased, these rocks released their trapped water in the form of steam, which eventually condensed into the oceans we have today. Think of it like a giant planetary kettle boiling away for millions of years, slowly filling up the world's oceans. However, it's not an either-or situation. It's likely that both these processes worked in tandem, with comets and asteroids bringing in external water and volcanic activity releasing internal water. What's truly fascinating is that the water you drink today, the water that fills our oceans, rivers, and lakes, has been on this incredible journey. It has survived the violent birth of our planet, endured countless asteroid impacts, and emerged from the fiery depths of the Earth's crust. Yet here it is, in your glass, hydrating you, sustaining life. So next time you take a sip of water, remember it could have traveled millions of miles just to quench your thirst. What if I told you that the oldest living organism on Earth is over 80,000 years old? Yes, you heard it right. We're talking about a life form that predates the invention of the wheel, the rise and fall of ancient civilizations, and the dawn of human history itself. This ancient being is not a dinosaur, not a fossil, but a tree. An extraordinary tree known as Pando, the trembling giant. Nestled in the Fish Lake National Forest of Utah, United States, Pando is not your average tree. This grove of quaking aspens is actually a single organism, connected by a vast underground root system. This remarkable giant spans over 100 acres and weighs a staggering 6,000 tons. But it's not Pando's size or weight that's truly extraordinary, it's its age. Pando is believed to be at least 80,000 years old, making it one of the oldest known living organisms on our planet. Pando, Latin for "I spread," is a fitting name for this organism. It reproduces through a process known as vegetative reproduction, where new trees sprout from the root system of a parent tree. This ability to clone itself has allowed Pando to survive millennia, enduring harsh climates and changing environments. But Pando is not just an ancient relic. This trembling giant plays an essential role in our planet's ecosystem. Its vast root system helps prevent soil erosion, its leaves provide food for various wildlife, and its dense canopy offers shelter for countless species. Pando is a living testament to the resilience of life and the intricate connections that bind our planet's ecosystems together. However, Pando faces threats from grazing animals and human activities that could jeopardize its survival. This serves as a sober reminder of our responsibility to protect and preserve our planet's ancient wonders for future generations. So there you have it, an 80,000-year-old tree that's still growing strong. Life, it seems, is full of surprises. From gas and dust to a thriving blue planet teeming with life, that's the incredible journey our Earth has taken. We've explored the mysteries of our planet's formation, born from the swirling dust and gas of the early solar system. We've delved into the cataclysmic Theia impact, a colossal event that shaped our world and gave us our moon. We've uncovered the origins of Earth's water, that elixir of life, tracing its roots back to ancient comets. And we've marveled at the resilience of life embodied in the oldest living organism on our planet, a tree that has stood tall for over 5,000 years. Each piece of the puzzle adds to the rich tapestry of our planet's story, a story that continues to unfold with every scientific discovery. So the next time you gaze upon the night sky, remember, every planet has a story to tell, and ours is just one among many.